program, go to beginning. And it's a 90-degree arc, another 90-degree arc, and then the same thing mirrored coming back the other way, but 25 thousandths over, and then repeating it, and X offset to end up where I want to finish with the 1/2-inch ball end mill. I did the math and came up with the offset of 0.0497, and then I'm doing 80 repeats on the back and the forth to end up where I want to be. And so we'll look, and that's basically what you end up with. You can do any size, you can do it tapered, which is a lot more challenging. I'm still working on figuring that out, but and the way you set it up is you use tool center, and then as you can see, tool 1, and if you look at tool 1, I had to set it at 0. I don't know if it was a glitch or what, but it started on center one direction, but was like it was offset in the other direction, so it didn't end up on the part where I wanted it to be, and it took me a minute to figure it out that I had a tool diameter in there, and so I set it at 0 and it solved it. And ball end mill, and so you set up your 0 for your tool. I'm using a 1/2-inch ball end mill, so the radius is 0.25, and so you need to set up, you're going off of the center of the ball for all of your measuring, basically, for your machining, and so the center of the ball will be 0 at the top edge of the part, and since it's a 1/2-inch ball end mill, when I touch it off, then that'll be at 250 thousandths or a 1/4 inch above the part, is where 0 will be when you touch off on the top. And so I roughed out the whole part with a bunch of rectangular pockets to get the main portion of the material out of the way, and then I set this program up. Now the reason why it's each pass is 2 90-degree arcs is because for some reason, if you program in an entire 180-degree arc rather than going through Z like you want it to, the software flips it on edge, and so you're going in 2D. But if you do a 90-degree arc down to the center of the part, which it's a 6-inch part, so the center's 3 inches, and then the next 90-degree arc starts there and comes up the same amount, then it knows what you're trying to do and does it. And then I just did a mirror at the 3-inch line and scooched it over. Let's go back. 1/525 is where I'm starting, and so my return pass is 1/550, so I scooched it over just 25 thousandths. And as you can see, my Z rapid I made at 250 thousandths above the part, just in case, because I didn't want to crash that ball end mill down into the part before I had roughed it out. And that just, I don't know, little peace of mind there. Gives it a starting run at it. So we'll go to run and start. need to do the mirror, you can just offset it and repeat, but it'll go back over and start from the same side every time, so you'll be wasting a little travel time. Is the reason why I did the mirror and cut backwards, so that it would cut in both directions. And it was nice because both end cuts ended up being a climb cut, so it had another benefit that I hadn't really thought about. Stop it on the next pass and then speed it up. Go into program. RPM, I'll go to 3,000. Feed rate, Z, I'll go to 30. And XYZ, I'll go to 30. And still tool 1. this is the size of the part. It was 7 inches 50 thousandths long by 6 inches tall by 2 inches thick. And then the diameter is 3 5/8, so I went half of that as this radius, and then I offset it 1/4 of an inch for my ball end, so I can run just on programming tool center. And so I ended up, that was my starting point in Y. And then of course the center is 3 inches. And then the ending point of Y is 4,563. The diameter is 1,563, or the radius I mean, which is the depth also. And then my sides are 1 inch 275, and so I added the 1/4 inch radius for the 1/2 inch ball end mill. So 1,525 was my starting point, and 5.525 was my ending point. And that's pretty much it. It was pretty simple. Don't know why it took me so long to figure out, and a lot of phone calls and looking at YouTube, and I couldn't find anything on there, so I figured I would share it. So of course, any size ball end mill you would use, you would program it on the tool center, so that would be the radius of the tool. As far as finish passes, I guess you could offset it up 10 thousandths or something, or do the initial passes with a sharpened ball end or a little bit smaller diameter, because when you're going off of tool center, you can't cheat and change the tool diameter to get a finish pass. I don't know, there might be a better way, but I haven't figured it out yet. But that's pretty much it. If I figure out anything else interesting to do on this, then I'll make a video and post it also. Seeing as how you start off with just an arc, your one programmed arc you could rotate, so you could basically make a billet cereal bowl, or you could make a dome by just rotating one arc or one back and forth arc. So yeah, there's a lot of different things I think you could mess with to do this. But thanks for watching, and that's pretty much it. And that's with the Proto Trak SMX controller on the new Trak DPM2. And we'll see what we can figure out and make it do.